Hello all. In this video, we are going to learn about IoT connectivity. So, IoT connectivity means it is like the communication protocol which the input signal has to follow while traveling from the sender to the receiver. So, these are the different types of communication protocol. So, probably in this video, we will be learning about the IEEE 802.15.4 protocol and the ZigBee protocol. So, these are the communication protocols which we have for Internet of Things. 6LoWPAN, wireless HART, Z-Wave, ISA 100, Bluetooth, NFC, and RFID. RFID is nothing but the radio frequency identification. So, the very first one is IEEE 802.15.2. This standard provides a framework meant for lower layers MAC and PHY for a wireless personal area network. PAN means personal area network. LAN means local area network. Wide area network is nothing but WAN. PHY is defines the frequency band, transmission power, and modulation scheme of the link. MAC defines issues such as medium access and flow control frames. This standard is used for low power, low cost manufacturing and operations, low speed communication between the neighboring devices. So if there are two devices, maybe the sender and maybe the receiver, if the distance between the sender and the receiver is low, if I don't want to spend much power, much cost, if I want low speed of communication, then in that case, I can go with IEEE 802.15.4 communication protocol in Internet of Things. So we have some features of IEEE 802.15.4. This uses the spectrum. Spectrum means it's the frequency band in which the signals will travel. This standard utilizes direct sequence spread spectrum coding scheme to transmit the information. Direct sequence spread spectrum is the sequence which is used to send the signals. DSSS uses phase shift keying modulation to encode the information. When we are sending the information from the sender to the receiver, in order to reduce the correction of data. Okay, correction of data means it's the change in the information. Maybe some information will be deleted during the transmission, some information will be added during the transmission, some extra information will be added, some information may be replaced. These are called as correction of data. These correction should be reduced. To reduce these correction, we have to encode the data while sending and we have to decode the data while receiving. For that, we are making use of phase shift keying modulation method to encode the data. Binary phase shift keying method is a method to encrypt the data. So that uses a frequency range of 868, 915 megahertz, and the data transmission in the form of packets will be at a speed of 20 kbps or maybe at 40 kbps. So next one is OQPSK, which works at a frequency range of 2.5 gigahertz. Data transmission rate will be in the range of 250 kbps. So when the data transmission rate is high, the phase shift keying or encryption will also be more efficient and the cost will also be lower. DSSS scheme makes the standard highly tolerant to noise and interference and thereby improving the link's reliability. So the next is features of IEEE 802.15.4. The preferable nature of transmission is line of sight. It transmits, the data will be transmitted in the form of packets. The standard range of transmission will be in the range of 10 to 75 meter. The transmission of data uses carrier sense multiple access with collision avoidance scheme. Carrier sends multiple access with collision avoidance scheme. Collision avoidance means the clash of data. So these are the variants of IEEE communication protocol. The variants are like 802.15.4, 2003, 2006. So the other versions are also there, which is nothing but 802.15, 4.A, 4.C, and 4.D. 4.A was invented with two physical layers. 4.C was invented in China. 4.D was invented in Japan. I hope you would have learned from the video. See you in the next video. Until then, it's bye bye from Radhika.